Now think about motion in a circle. Let's say that's a circle, and I have a ball moving round the circle. So the ball follows the circle and it goes round and round. So that's the direction of motion of the ball. And now I want to think about the force acting on the ball. We understand from Newton's first law that if there's no force on the ball has to go straight and it has to carry on going in the same direction with the same velocity, unless there is a force acting on it. There's a force that changes this. So clearly, if it's going around in a circle, there must be a force, right? If not, it would just go straight. Okay. So question now is, which direction is this force acting on? The force must clearly be pushing on the ball, but where is it? In which direction is it pushing the ball? Okay. The obvious direction, when most people think about motion in a circle, the obvious direction that they will think about is in the direction of the ball. So if, let's say, the ball is going this way, right, as it goes round and round, let's say at this time the ball is moving in that direction, then clearly the force must be in the same direction as the velocity. The force has to be in the same direction as the velocity. I mean, the ball is moving this way, so the force must be pulling the same way. That's the easiest way to think about it. Now, unfortunately, this is completely wrong. This is completely wrong, and you'll find that it's actually not easy to explain why this is wrong, and I've met people who firmly believe that the force has to be in the same direction as the velocity. Now, when we learn physics, we have to understand that if there is a force pulling on the ball, okay, the ball will change velocity in the same direction as the force. So in other words, if my original velocity is in this direction and I have a force in the same direction, the velocity will increase in the same direction as the force. In other words, the ball has to keep going in the same direction. So there is no way it is going to go round in a circle if you apply a force in the same direction as its velocity. Okay? How else would you make the ball go in a straight line? But by applying a force in the direction of its motion. So something is not right if we think that the force is in the same direction as the ball. In other words, the force has to be in some other direction. And it's not too difficult to understand which direction, or even to guess which direction. You see, if I have no force, this ball will just go straight. Okay. Now, if you have an object that is going straight, imagine what happens if I want to push it sideways. I would just apply a force at right angles to its motion. If I apply a force at right angles to its motion, it will start bending in that direction. Now, again, this is not something that is very easy to understand, because it is easier to just think that if the ball is moving this way, when I apply a force to it, the ball must surely just start moving at right angles to its motion immediately. Okay. Now that doesn't happen because the ball has momentum. So as I apply a force at right angles to it, the ball will start moving in that direction, yes, but it must also carry on with a momentum in its original direction at the same time. And that's why the combined effect is that it curves. Alright, it still goes in the original direction, but at the same time, it gains the velocity in the perpendicular direction. And that is the same thing when you throw a ball horizontally. Okay, the ball falls to the ground in a curve because there's the force of gravity pulling it down. But the ball doesn't just, if you throw a ball horizontally, the ball falls to the ground in a curve because there's the force of gravity acting down on it. The ball doesn't just fall straight down the moment it leaves your hand, right? Because it has this momentum, this horizontal momentum when it leaves your hand. So it is always a combination of two velocities, the original velocity and the increase in velocity from the acceleration due to the force. So coming back to this motion in a circle, we have some idea that now that it is more logical to think that the force that is needed to cause a ball to move around in a circle cannot possibly be along the same direction. It has to be in some other direction. Now, I gave this example of a perpendicular direction, but it doesn't have to be perpendicular. It can be in a slanted direction as well, if we just want a curved motion. Okay. But later on, we'll see that for a uniform motion in a circle, that means at the same velocity, at the same angular velocity, the force has to be perpendicular. So we'll see why later on. So hopefully that dispels one common notion about motion in a circle. Now there's another common misunderstanding about motion in a circle, and this is the idea, this is what we often call centrifugal force. Centrifugal force. Okay, centrifugal force is something that we would all have experienced if we ever sit in a car or a bus going round in a circle. So let's say I have this, I'm sitting in this car. Okay, so there's this little car here, the wheels here, and the car is going this way. Okay, and I am standing or sitting in the car. I'm sitting in the car or the bus, right? I'm standing on the bus. So as the bus turns one way, okay, as the bus turns one way, I will feel myself being pulled the other way. If the bus turns very quickly, I will find myself being forced against the outer side of the bus. So obviously, the natural conclusion would be that there's a force pulling outwards. So if I go around in a circle this way in a bus, right, the obvious force would be away from the center of the circle. It would be away from the center of the circle. Now, so I would obviously think that the force that acts on me, right, as the bus goes around in a circle, is away from the center of the circle. But that again is completely wrong. But if it's so obvious, how can it be completely wrong? Okay, right. Now, let's forget about the bus for a moment. Okay, let's forget about the bus. Let's say there's no force. Let's say I am moving with a certain velocity. I'm just moving with a certain velocity v. there's no bus around me, right? No bus to carry me around the circle, but I am just moving with this velocity somehow. Then I will just keep going straight, right? According to Newton's first law, I'll just keep going straight. If let's say I'm just floating in outer space in this direction, if there's actually a force pulling in that direction, surely I would start bending that way. Why would I go the other way? So this is one reason why the force can't be pulling me away from the circle. So if the force is not pulling me away from the circle, if there isn't a force pulling me away from the circle, why do I feel myself being pressed so hard in this outward direction? Now the answer is actually lies in Newton's third law. See, in order for me to go round this way in a circle, in order for the bus to carry me around this way in a circle, the bus has to apply a force on me towards the center of the circle, that way. See, if there's no force at all, as I suggested just now, I would just go straight, right? If I'm in outer space and there's no force, I would just float straight in that direction. But in order for me to go around this way, to go left around the circle, the force must be towards the, or at least roughly, towards the center side of the circle. Okay, that in itself should be reasonable. Okay, but the question now is, why do I feel myself being forced against the other side? Now the reason is this: in order to bring me around this circle, the bus has to push on me, right, towards this direction, towards the center of the circle. When the bus pushes on me, I would push back on the bus. Now I don't have to do anything. Just by the bus pushing on me, my body would have an equal and opposite reaction that pushes against the bus. And that's Newton's third law. When the bus pushes on me, when the wall of the bus pushes on me, my body pushes back on the bus. Okay, so it is this force from my body pushing on the bus that gives me the feeling that there's a force pulling me in that direction. In much the same as when I sit on a chair, my weight pull me down and I feel my bottom pressing on my chair. Okay, so when my body has this third law reaction that pushes against the wall of the bus, that gives me the feeling that there's a force pulling me outwards, away from the circle. And that's what we call the centripetal force. So whether it's for the ball on its own or for myself being carried on the bus, in order for us to go round in a circle, the force must always be towards the center of the circle. Okay, maybe not exactly, depending on if we are accelerating, changing velocity, but roughly towards the center side of the circle. Now this force that causes us to go around in a circle has a name. It has a proper name. And so that this force and this force. So the proper name for this force is called a centripetal force.